Section 2.1, frequency distribution and their graphs. Please pause the video to write down the objectives as essential questions. How do we construct a frequency distribution? So frequency distributions are for if you have a set of data, you're going to put them into classes and or intervals. So for this example, between 1 and 5 inclusive, we have 5 values in the data, or that class shows up 5 times. And there's a difference between a lower limit and an upper limit. The lower limits you can see in this picture now. And there's a class width, and the class widths are between each lower limit. So from one lower limit to the next, or from each upper limit to the next. So a class width 6 minus 1, you get 5. And then if you look at the next lower class to lower class limit, 6 to 11 is a gap of 5. And if you take the minimum 1 and the maximum 30, you find the range. When we construct a frequency distribution, you will never decide on the number of classes that will be given to you. You're going to determine the class width using a formula. You're going to find the class limits, and then you're going to make a tally for each data entry and count the tally marks for the frequencies. Let's say we have this data set. Pause the video to read it. We're going to construct a frequency distribution that has 7 classes. So first, we have 7 classes. Now we're going to find the class width. You find the maximum and the minimum data value, 405 minus 155, and divide it by the number of classes. But the thing about it is we're always going to round up. If we round down, our classes won't include the maximum value in the data, so you have to round up. So 35.71 will round up to 36. So you start your frequency distribution with the lower limit, 155, and you're going to add 36 to that value. You get 191, and you keep adding 36 on and on to get the values. Then you're going to find the upper limits. Well, the upper limits can't go past the next lower limit. So if 191 is the next lower limit, you're going to have your first upper limit being 190. So that way it doesn't overlap. And then you can use the class width from there on to find the remaining upper limits. So add 36, add 36, add 36, and so on until you fill up your upper limits. Then you go through your data and you start trying to figure out how many times do the values between 155 and 190 inclusive show up. You put down a tally and you cross out the values in the list and you create a frequency. And you always want to check to make sure that the sum of the frequencies actually add up to the total number of data values in the set. Sometimes we're going to use the midpoints to represent in a graph. So to review a midpoint formula, you take the lower class limit plus the upper class limit, divide that sum by 2. So the midpoint of our first class is 172.5. After that, you can use the class width of 36 to find the remaining midpoints. So add 36, the next midpoint will be 208.5. Add another 36 and you find the next midpoint. Another column within a frequency distribution could be relative frequency, where you take each frequency and divide it by the sample size. So the first frequency in our notes is 3. That first class shows up 3 times in the data, and we'll divide that by 30. Then you have cumulative frequency that you can keep track of. And so we'll see it in the next example. Okay, so first thing is after we figure out our classes, class lower and upper limits and we count the values in the data, then let's fill out the rest of this table. Midpoints, we've got the formula for that. So 172.5, you can keep on adding 36 each time or do the individual formula every single time. Relative frequency, you take each individual frequency and divide it by the sample size, which is 30. And so you get 0.1 and you can continue. So the whole 36 class width rule doesn't fit here. You have to take each individual frequency and divide it by the sample size. Cumulative frequency also can't deal with the 36 rule or the class width rule. Cumulative frequency, you start out with your very first frequency, 3. And then you're going to add on the next class frequency of 2, which will get 5. And then you add on the next class frequency, and then you get 10, and so on. And that develops your cumulative frequency. We use these values or these columns for different graphs. So let's talk about these different graphs that we'll see throughout this year. Okay, frequency histogram. We're going to have another column added on because a histogram has its columns touch each other. And in order to do that, we have to adjust our class limits so that way they touch each other. And the way we do this is by subtracting a half and adding a half on each lower class and upper class limit. So you can see how these class boundaries subtract a half on the lower limit, add a half on the upper limit. And when we do that, we could either use the lower class to upper class boundaries as our x-axis, or we could use the midpoints as our x-axis. But notice how the y-axis is still the frequency values. Another graph is the frequency polygon, and it's a line graph where it connects to the x-axis on both ends. Well, in order to do that, we use our class midpoints. But wait a second, when you hit 172.5, you're technically supposed to have a frequency of 3. So how do you start on the x-axis where you're supposed to have a 0 for the frequency? So what we do is we subtract 36 on both below the first midpoint and above the last class's midpoint. And that's what you see here in the explanation if you want to pause. But if you subtract 36 and add 36, you'll be able to connect to the x-axis. We will discuss how to graph this on a TI-84 in class. So relative frequency histogram uses the relative frequency column. And we also are going to use the class boundaries to make sure the columns touch, or we could use the midpoints as labels. This is an example where it uses the class boundaries, but notice how the y-axis uses the relative frequency column. And so there's this ogive where now we're going to use the cumulative frequency column where you start on the x-axis and eventually you end up with the sample size as your cumulative frequency. So you can pause and read through the directions. We're going to start with the lowest class boundary, and then we're going to flow using the upper class boundaries and label the cumulative frequency. Because technically in our data, if we started with 154.5, there are no data values that have 154.5 or lower, because cumulative is what happens to you now and below. And there's nothing in the data that represents that. But once we hit 190.5, we've reached 3 data values. Then when we get to 226.5, we've now reached a cumulative 5 data values. And so I want you to pause and highlight accordingly how I do in the video. And then notice this x-axis. 154.5 starts on the x-axis, starts on the x-axis. And then as we progress, we end up with the sample size. We will discuss all this technology in class. Thank you.